Good afternoon to everybody. I'll just take a cue from what Christina said on how important process safety is in any process industry. While we have various kinds of process safety, I would restrict myself to just the rotating equipments A or to static equipments wherein we have leakages and emissions emitting out of these equipments. In any process industry, a simple shaft or stem sealing in any rotating or static equipment is considered to be the heart of the plant. It's also the most delicate part of the plant because if one of the sealing systems in any of the rotating or static equipment gives way, we have issues as in the process plant can come down, maybe for a few hours, maybe for a few days. Moving towards improved MTBR and a light on what I'm going to throw on how emissions can be contained both in rotating and in static equipments. Back in the 1994, we had the API looking at the possibility of improving the mechanical seal life in all rotating equipment. And that's when came up the API 682, a document which since have moved into the 4th edition as of 2021. Typically, when you see in mechanical seals, the leakages occurred across the shaft, the sleeve, and across the seal faces. To improve these lives, the first and foremost that they put in is the removal of any plastic sealing systems on this, for example, Teflon, and introduced elastomeric, namely either a fluoroelastomer as in Viton or a perfluoroelastomer as in Calrus. So why are we so keen that we need to improve our mean time between failures? 2 reasons. One is with increased failures of equipment. Here, as in centrifugal pumps, we have the mechanical seals. The cost for the industry rises drastically. 1. 2, both in terms of cost of the mechanical seals and other hardware involved, plus the process loss because of production loss because of the downtime. When we talked of sealing, we talked of the fluoroelastomers as in Viton, but we didn't talk much about the perfluoroelastomers as in Calrus. In today's industry, across all refiners, we have only one aspect when we change to a perfluoroelastomer, as they say, we need a perfluoroelastomer as in Calrus. But in each of these perfluoroelastomers, we have a variety wherein each particular process would need a different perfluoroelastomer. By ensuring that we have the right perfluoroelastomer, we can improve the mean time between failures in each of these rotating equipments. The most important thing which is involved in these perfluoroelastomers is the fact that the swell involved due to the process that it is handling could be varied starting from a 5% swell right up to 15% swell. When the swell of the O-ring goes up to as high as a 15%, what actually happens is the equipment fails and the mechanical seal tends to leak, by which we have 2 problems. One is the production loss or the failure in the equipment. And the second is the process liquid coming out into the atmosphere, by which we have emissions coming into place. By using the right elastomer across for all your equipments would only help you in improving the mean time between failures. The second point that I was trying to highlight here is on the emissions that are being seen out of the process industry. Most emissions that occur in a refinery is through the flare. The second is through various rotating equipments like the compressors, pumps, and the last one being the valves. Valves being a static equipment, we tend to use a graphite packing typically to seal the valve stems to ensure there are little emissions. However, as all process people would agree with me, we tend to go tighten the glands time and again to ensure we are able to keep the leakages well below the prescribed limits. Today, API specifies for these greenhouse emissions that the emission level should not exceed higher than 100 ppm. What we see in a plant today is emission levels ranging from anywhere between 1,000 to 5,000 ppm. Imagine a plant shedding out emissions to a level of an average of say 1,500 ppm. It actually enhances the amount of emissions that are there in the atmosphere. It's kind of how it's going to work on the safety of the people working there. And plus, it adds up to the climate change. Calrus valve stem packings, if introduced in each of these valves, tend to ensure we are able to keep the emission levels to as low as 5 to 20 ppm. What's more important is, in the event of any upset condition inside the process, these stem packings automatically work towards a situation wherein the tightening of the valve stem packing happens, yet the emission levels are still contained to a level between 5 to 20 ppm. Maybe there's a process change in temperature. Maybe there's a process change in terms of pressure. Maybe there's a process change in terms of change of fluid that you're processing through the valves. The second point which is important here while using these valve stem packings is, once installed, you do not need to personally monitor these valves every week as is normally done in any refinery. You tend to monitor this maybe once in 6 months just to reaffirm that the emission levels are low. These are self-acting by which we are able to achieve the required levels of emissions. Now, what happens when you have problems occurring in your valves? More often than not, we tend to replace the entire valve. We tend to change the stem. We tend to change the packings. And notwithstanding all that, we still live with the emissions that these valves emit out. Now, with this in place, we have, just for an example for you, we have been able to put it across to a major refinery in India, south-based refinery, wherein approximately 2,800 valves were installed with these Calrus valve stem packings. And the levels of emissions that we are noticing there is anywhere between 5 to 25 ppm. With this, we are able to, 1, improve the mean time between failures, 2, reduce emissions, which are quite a bit as we see it. Thank you very much.